All right, welcome aboard. Today we're going to be talking about first order separable ordinary differential equations, or ODEs. We're going to break it down for you BRNY style right now. So we're going to start with an expression. Here we've got y prime equal to 2x divided by 1 plus 2y with an initial condition where y of 2 is equal to 0. So when we call something separable, we want to think of the word separate. Separate as in separate the x's and the y's. Meaning let's put all the y's on the left and all the x's on the right. The standard form for a separable ODE first order is n of y times y prime equal to m of x. Now in this case, we're going to take a look. We're going to have our n of y is going to be 1 plus 2y, and our m of x is going to be 2x. So what we'll do is we'll go ahead and wrap this one in parentheses, multiply both sides by 1 plus 2y, and we'll end up over here at 1 plus 2y times y prime is equal to 2x. Now that we've separated our variables, y is on the left, x is on the right, we'll integrate both sides. Our integral on the left has two components, a and b, because we're going to use the sum rule here. And our expression on the right has one component, c. So let's take a look at these components one at a time. Our component a was 1, so the integral of 1 dy is just equal to y. And component b, the integral of 2y dy is going to be equal to 2y squared over 2, because we use the power rule, right? Y is the same as y to the 1. Y to the 1 plus 1 gives us y squared over n plus 1, which was 1 plus 1, 2. And then our 2's will cancel, leaving us with y squared. Our third component, c, over here, is going to be the integral of 2x dx. Again, we're going to use the power rule. This is 2x to the 1. So this is going to be x to the 1 plus 1, which is x squared, all divided by the n plus 1, which was 1 plus 1, or 2. We'll keep our constant over here and cancel our numerator 2 with our denominator 2, leaving us with x squared. Now we'll just go ahead and put all of our answers for our three components back into our equation, and we're going to be left with y, because a was y, plus y squared, because b was y squared, equal to x squared, because c was x squared, plus c. So here's where we'll add our integration constant, right here, c. And now we will apply our initial condition. Y of 2 is equal to 0, meaning x is 2, and the function is equal to 0, y. So we have 0 plus 0 equal to 2 squared plus c. We do the arithmetic out, we got 0 is equal to 4 plus c, which tells us that c is equal to negative 4. So now we're just going to go ahead and plug our negative 4 back into our equation here, and we'll be left with our final answer, y plus y squared is equal to x squared minus 4. And that's first order separable ODEs BRNY style.